Hi, my name's Bruce and this is a video about shaft straightening. This is the shaft. It's the worm shaft from a rotary table. I bought a rotary table at an auction for a great price and got it home and found that it was kind of stiff. And turns out that it must have been dropped at some point, and this shaft was binding in its bushing. And it is in fact bent, so to try and rescue it, we'll try and straighten it. So this is the setup I'm going to use. I've got the shaft sitting in V-blocks with a small piece of aluminum at two places for it to run on as a bearing and provide a point of contact. Dial turning indicator to measure the run out, and the whole thing is sitting on a fixture plate in an arbor press so that I can do some pushing around. So here I've zeroed the dial and just turning by hand. It's about 3.5 thou high, that's the high point there. Yeah, about 3.5 thou total indicator. So I figure it's important to know what the shape of the shaft is when it's bent. It could be just a simple bend in the middle, it could be a couple of bends, it could be bends in different planes. So I think it's important to know what you're dealing with. So I measured runouts everywhere I could and I plotted them, and these are the points that you can see. So these two sections here are the journal sections where the shaft runs in a bushing here. And then in the middle there's kind of a relieved section, slightly smaller diameter. It's about 3/4 of an inch, it's 17 millimeters. And I used a flat tip on the dial gauge to measure the run out on the top of the worm teeth. A little bit rough, but and it actually went the opposite direction. So what I think is going on is that the shaft is relatively straight right through this section here, and certainly here where it's bigger diameter you'd expect that, and then there certainly seems to be a kink here. So what I think is the shaft is straight here and then bent here, so I think that's the shape of the shaft. So therefore what I want to do is just push that back from this point. So this is going to be the point of focus. Okay, so here goes nothing. I've marked the high point with a line so I can always find that. And now I'm going to try pressing. It's now $5 thou. And I'm going to try some run out now and see what happened, if anything. In fact, I need to move back to a surface that I can get at without disturbance. So that looks like about 2.5 thou and at the same high point. So I haven't done enough and might have done just a hair of straighter. So next thing, a little more. So that's 2.5 thou, looks like not doing anything. It was 6 thou of deflection on the arbor press, and it looks like it's still at 2.5. And the same high point. So that was 8 thou. And after that, it's about 2 thou. So it's actually moved 1/2 thou. 2 thou, yep, definitely 2 thou, not 2.5. And at the same high point. So it's moved in the right direction, and it took 8 thou of deflection to do that. Okay, so here we go again. That was 10 thou, and it's starting to get quite hard to pull on this little 1-ton arbor press. So go figure. It's now at 2.5, 2.6, something like that. So that looks like worse than last time. And the high point is still the same place. So after working my way up to 25 thou of deflection, I'm now less than 2, and the high point has moved a little bit. So that's the old high point there, and that's only 1 thou now. And there's just short of 2, so something's happening. It's moving. Cool. So now I'm at just about 1.5 thou, and interestingly the high point is now starting to move around. The high point is now back to where it was to start with. I like to visualize the shape of the shaft, so what is here is a three-dimensional sketch, if I can say that, of the shaft and the runouts. I've measured the runout at 4 clock positions, 12, 3, 6 and 9, sketched the axes and then plotted those positions. So for example, the biggest runout is here, and the size of the runout is this big, and it's kind of down from below 9 o'clock, before 9 o'clock. So it's like 8 o'clock position. So what that means is when I try and straighten that particular piece of the shaft, I will press on it from 8 o'clock and support it somewhere here, not at the ends of the shaft. And then I'm kind of isolating this area and hopefully only straightening that particular piece. So that's the principle. Similarly, this one is kind of a 10 or 11 o'clock position, so I would push on it in this direction and support it in this direction. So depending on how it turned out after doing this one. So here's the state of play now. At this location, that's the high point there. So we have, and that's 3 o'clock. There's -1/2, and that's the oil groove. -1/2, and back to 0 at 3. So yeah, I've got 1/2,000, and that's the biggest deviation so far. If I go in the middle of the journal, so what's that? Oil groove's annoying. About 3 or 4 tenths over at this end. Where's the high point? I expect high to be at 3. Now that's just wavering around a needle width, so 2 tenths, something like that, ±2 or 3 maybe. So it's not looking too bad. So this is the rotary table with the straightened shaft, everything assembled, and serviceable. Not perfect, but serviceable. So that'll do for me for the moment. I hope you have found something interesting in this video, and bye for now.